Understanding the CPU. In every modern computer, whether it's a high-powered gaming system, an office desktop, or the smartphone in your pocket, the central processing unit, CPU, plays a crucial role. Often referred to as the brain of the computer, the CPU is responsible for executing instructions, managing data, and coordinating the operations of all other hardware. Although small in physical size, its impact on a system's performance is immense. What the CPU actually does. At the core of its operation, the CPU follows a simple but rapid cycle known as fetch, decode, execute. First, it retrieves an instruction from memory. Next, it interprets what that instruction means. Finally, it performs the required action, whether that involves solving a math operation, moving data, or making a logical comparison. This cycle repeats billions of times every second in modern processors, allowing even complex software to run smoothly. The inner workings of a CPU. Inside the CPU, several key components handle different tasks. The arithmetic logic unit, ALU, performs mathematical and logical operations, while the control unit directs data flow and orchestrates how instructions are processed. Small, high-speed memory areas called registers store information the CPU needs immediately, and layers of cache memory help reduce delays by keeping frequently used data close at hand. Together, these components form a compact system designed for speed and efficiency. Advanced abilities of modern CPUs. Today's CPUs are far more capable than those of earlier generations. One major advancement is multi-core design. Instead of relying on a single processing core, modern CPUs often contain 4, 8, or even more cores, enabling them to handle multiple tasks in parallel. Another innovation is multithreading, which allows each core to manage multiple instruction streams at once, improving performance in multitasking and complex applications. Clock speeds, measured in gigahertz, also remain a key factor, indicating how many cycles a processor can perform per second. But modern CPUs balance speed with power efficiency, especially in laptops and mobile devices where battery life is critical. Some CPUs also include integrated graphics. These allow the processor to handle basic visual output without the need for a dedicated graphics card, which is useful for everyday computing. Working with the rest of the system. While the CPU is central to computing, it doesn't work alone. It constantly communicates with RAM, where active data and instructions are kept. It also interacts with storage devices, graphics processors, input-output hardware, and the motherboard, which connects all components together. Because of these relationships, overall system performance depends on how well the CPU and the rest of the hardware work together. Why the CPU matters. The CPU influences nearly every aspect of your computing experience. It determines how quickly applications open, how well games run, how smoothly multitasking feels, and how responsive a system is overall. Even battery life can depend on how efficiently the processor uses power. Whether you're building a computer, buying a new laptop, or simply curious about how your devices function, understanding the CPU gives valuable insight into what makes modern technology fast, powerful, and efficient. I thought I should make another because this is fun and again. Thank you for watching. Like and subscribe, and read this and other articles at my website in the description.